All right, learning target number 3. I can relate intermolecular forces in the process of solvation. All right, so solvation, first of all, um, when there is attraction of the solvent for the solute particle. So biggest thing as we look at water, water has a positive end, um, and which tends to be the hydrogen end a little bit more, and then the oxygen is a little bit more negative. Okay, so what happens if we have our ionic crystal? Okay, the sodium has a positive charge, chlorine has a negative. So what happens is oxygen, or water, here's our water, okay, this end tends to be a little bit more negative. These ends are a little bit more positive. All right, so what happens is this negative end attracts it and the Na is going to pull off. Okay, the positive end of the water, okay, is going to pull off that chlorine and it's going to separate. So now we have sodium ions and we have chlorine ions. All right, and another thing with polarity, or with the intermolecular forces, is it deals with likes dissolve likes. Okay, so polar water is going to pull apart polar substances, or ionic compounds have charges. So anything that has charges, water is going to be able to pull apart. Okay? On the other hand, oil, all right, it does not have a positive or negative ends on it whatsoever, and that is why water and oil don't mix. Okay? Likes dissolve likes. So that's another part with this, is that if you have the same type of molecule, polar versus nonpolar. All right, polar substances will pull apart polar, nonpolar will pull apart nonpolar. Okay, so that's number 3. That's what it was talking about. Number 4 deals with solubility. So solubility is something soluble and does it dissolve? Okay, if it does not, so solubility means dissolving. Okay, the maximum amount of solute, all right, that will be dissolved in the given amount of solution. Okay, so if it does dissolve, it's going to be called soluble. I didn't spell that right. We're just going to label it like this, soluble. I still didn't spell that right, but whatever. All right. This means that it's able to be dissolved. Okay, if it's insoluble, okay, that means that it will not, okay, dissolve in that liquid. Okay, it will not dissolve it at all. So insoluble does not dissolve, soluble means it will. Okay, now you might get to a point of where you add too much, all right, and so there's no longer any more being dissolved in it, so that would be a saturated solution. But some solubility determines the amount, okay, so you can figure out how much is going to be able to dissolve, what is its solubility limit, okay, and so then the next part, identify factors that are affecting it. So first of all, pressure is one. All right, so pressure affects how much something will dissolve, especially with gases. Okay, the more pressure gas is under, the more it will dissolve, the more that it will be soluble. Okay, temperature is another. Okay, with all. All right, and then the last one is called the nature of the. Okay, so the nature of the solute and the solid. All right, are they similar? Are, just like the slide before, likes dissolve likes. Okay, are they similar? Are they both have charges, things like that? Are they able to pull each other apart? Okay, if they're not, then they're not going to be soluble. They will be insoluble. All right, oil and water. All right. Number 5, can I calculate the concentration of solutions in terms of molarity, percent by mass, and parts per million? Okay, parts per million. We did not do anything math-wise with it, but just knowing that it's a very, very small amount. Okay, it's really a diluted concentration, but it still means something. All right, so for number 5, It's a problem. So what is the molarity of the solution that contains 6 moles of solute in 2 liters of solution? All right, so we know molarity, big M, equals number of moles per liter. All right, so if we look back at this problem, oh, we have moles. All right, so this is our N, and we have liters, which is our L. So I would just plug it in. I would have 6 moles over 2 liters, right? So I would get 3, either you can say moles per liter, or you could say it's 3 molar, okay? Make sure you put that big M. If you put little m, that is considered meters, okay? The next one, all right, how many grams, so I'm looking for grams of NaCl are needed to dissolve enough water to make, oh, here we have the volume, and I have a molarity of a solution, okay? The molar mass, so I'm giving you the molar mass, is 58.5 grams per mole, okay? So I know this equation, big M equals number of moles per liter, all right? Well, this is M, this is L, right? So I know this, I know this, I don't know my number of moles. I know that moles can get me to grams, so I need to figure out my N. So N is going to equal molarity times my liters. Okay, so I'm going to get 2.5 liters times 1.75 molar. Okay, and remember, this big M stands for moles divided by liters. Okay, so liters would cancel each other out. All right, and I do not have a calculator. All right, so we multiply those. 2.5 times 1.75. So we end up with 4.375 moles NaCl. Okay, but I'm not done. I want grams. Okay, so I'm going to take my 4.375 moles. Okay, I'm going to convert it to grams. So I know 1 mole equals 58.5 grams because it tells me that up above. All right, and I'm going to get how many grams I have. Right, so I'm going to get 256 grams of NaCl in that solution. Okay, when I make that solution, I make 250 milliliters of it. I'm going to put 256 grams of sodium chloride in it. Okay, the percent by mass, we've already done that. Okay, we did that in the slide earlier. So this last one, all right, assume that a stock bottle contains 12 molar hydrochloric acid is going to be made up into individual 250 milliliter bottles of 0.5 molar HCl for the lab. Okay, how much of this? All right, so I'm going to put my M1. I'm going to always make my M1 the larger amount, so 12 molar. Okay, I'm reading my problem. This is my second thing that I'm going to make. Okay, so my M2 is going to be 0.5 molar. Okay, I know that since it says of right here, that these two must go together. So my V2 must be 250 milliliters. Now in these problems, you can convert it to liters. You don't have to, okay? I want to know how much of this do I need to make each one of these bottles. All right, so M1, V1 equals M2, V2. And I know I'm going to use this because of all those different situations, okay, because I have 2 molarities. I want to figure out volume, but I'm given a volume. All right, so V1 equals M2 over V2 divided by M1. So we plug in our numbers. Okay, notice I'm using all of my units so that I do not get things confused. Okay, molarity cancels out. I'm going to multiply everything. Okay. All right, so I am going to have a volume of my V1 is 10.4 milliliters. Okay, if I did not have this milliliters here, I maybe would have put liters, or I could have maybe put something else. Okay, so use your units, show your work, show me everything when it comes to those problems. Okay, we're gonna stop here. I will finish the last few on the last slide.